This section opens the book's central question about what technology fundamentally is. We know every electron's path through a microprocessor, yet we have no theory of what technology is. This is the same asymmetry. Cuvier's natural history held before Darwin, total command of the particulars, no principle binding them together. Arthur's opening names the missing ology and diagnoses why it went missing. Technologies were studied as black boxes, stand-alone objects with no insides, so their kinship and their origins stayed invisible. Picture lemurs and zebras with no anatomy to compare. The generative pivot is to open the box, to treat each technology as an inner anatomy. Once you do that, evolution, the descent of the new from the old, becomes an askable question. Innovation stops being unexplained creativity. This chapter is the book's problem statement: what technology is, where it comes from, and how it evolves. This section names the primitive that the whole book unfolds, so open the black box. The chapter's whole work is to replace variation and selection with the rule that actually generates novelty, which is combination. Variation and selection cannot produce radar by varying radio, because radar needs a different principle. Combination is the rule that does the generating. Every technology is a combination of prior technologies, each one seeded by a freshly captured natural phenomenon, and each new technology becomes a building block for the next. So the collection bootstraps itself out of itself, few to many, simple to complex. It grows as an autocatalytic set rather than a lineage. This is the primitive. The rest of the book unfolds. Its compression arrives in Chapter 1, Technology. Once a means of production is becoming a chemistry. The building blocks are elements, not organisms. The generative engine is recombination, not descent. This section explains what a technology is at its most basic. A technology is a means to a purpose, an executable. That single predicate is closed under decomposition. Every assembly, subsystem, and part doing a job is itself a means to a purpose. Hence, itself a technology, all the way down to the elemental. So, a technology is a recursive combination. Technologies within technologies, self-similar across 2 layers, or 9, with no characteristic scale. The chapter's move collapses: device versus process, instance versus concept, whole versus part into one repeating structure. Combination becomes the generative operation the rest of the book runs on. The jet engine's fuel system is a means at the scale of the whole jet engine rather than a miniature jet engine. It is self-similar in role rather than in form. This section explains what a technology is at its most basic and why that definition folds back on itself. A technology is a combination of components organized to express one base principle, and each component is itself a technology with the same anatomy all the way down. That recursion is the whole move. Arthur strips the word technology to 3 definitions, then shows that the singular kind shares a structure. There is a main assembly executing the principle, supporting sub-assemblies hung off it, and all of them in constant conversation. A jet engine and a computer program are identical in form. Horace's watch, which is Simon's parable, shows why parts cluster into modules rather than lie loose. Assemblies survive interruption, and they split out for separate improvement and swapping. The self-similarity is the seed. If components are themselves technologies, new ones form by combining old ones. This chapter builds the object, The rest of the book evolves. This section explains why every technology bottoms out in a natural effect. It borrows rather than invents. Strip any technology to its floor and you hit a natural effect. It does nothing to create, only harnesses. The hammer borrows momentum. The clock borrows steady oscillation. Radar borrows the echo of metal. This is Arthur's move. A technology is a phenomenon captured and put to use. More precisely, it is an orchestration of many, each captured module calling the others like subroutines. Hence, phenomena are the genes of technology, a fixed alphabet programmed into endless devices, the way about 21,000 genes program every organism. The generative primitive is the split from principle. The effect is free, given by nature. The principle is the human idea of using it. Predict the boundary and money works too. Its phenomenon merely behavioral, not physical. This section explains Arthur's third principle, the one that says where technology actually comes from. Peel any technology to its core, and you stop finding engineering. You find nature. A hammer bottoms out in momentum, transfer, a clock in steady oscillation, radar in radio, echo off metal. This is Arthur's third principle, the one this chapter installs beneath combination and recursiveness from before. A technology is a phenomenon captured and put to use. The generative move is a type distinction. A phenomenon is a mind-independent natural effect with no use attached. A principle is the idea of exploiting that effect for a purpose. Given any device, ask what effect it programs, and you can predict, as with Marcy and Butler's exoplanet wobble, that the answer is always several effects, orchestrated. This section explains what a domain is, and why design begins by choosing one rather than by inventing. A domain is technology in the plural, a world you step into rather than a device that does a job, a constellation of components with its own grammar of what combines. The chapter's move is this. Design does not begin by inventing. It begins by domaining, choosing which world to build inside. Digital, hydraulic, radio, each is a language, and a new artifact, radio, each is a language, and a new artifact is an utterance in it. The inversion, the argument turns on, is that the significant innovations are redomainings, carrying a purpose into a new world where more becomes accomplishable rather than better devices. Half a domain's power is its reach. Progress, then, is less invention than migration between worlds. This section explains what a domain is and why it reframes both design and progress. A domain is a language. It is the vocabulary of components that a family of phenomena throws off: electronics, photonics, the canal world, together with the grammar of how those components may legally combine. Arthur's compression carries the whole idea. An individual technology is to a domain as a computer program is to a domain. Once you see this, design stops being invention and becomes expression. To design is to compose an utterance within a chosen tone. You enter an object down into that world for what can be accomplished there, and you haul it back up and out. And progress ceases to be a parade of inventions. It becomes redomaining, re-expressing an old purpose, flight control or aircraft detection, in a newer language of the possible. This part explains where engineering novelty actually comes from. A new version of a known technology is undertaken only when something must differ. So every design project is a problem, and its finished form is a solution, a combination of assemblies. Here is the inversion that makes the whole account go through. Combination is never aimed at. It falls in behind intention, the way words fall in behind a thought. Design is expression. Routine day-to-day engineering therefore manufactures novel combinations as a byproduct of solving. The good ones propagate mimetically, acquire a name, and encapsulate into modules. The building blocks evolution recombines. The engine of novelty is thus ordinary problem-solving rather than rare invention. Darwin enters only downstream, winnowing already formed solutions. Combination generates abruptly, and selection is slow. Prevalence can lock in a merely good answer over the best. This part explains where the building blocks of new technology actually come from. They do not require invention. Routine engineering secretes them as a matter of course. Any new instance of a known technology has to differ somewhere, so it poses a problem. The finished design is then a set of solutions, nested down its hierarchy of assemblies. Reuse one of those solutions often enough, and it crystallizes into a named module, an element that stands ready for further construction. The generative act here is combination, and it is abrupt, not the slow variation of Darwin. Darwin enters only afterward, in the winnowing, where prevalence locks a solution in whether or not it was the best one. That is the chapter's hinge for part 2. Novelty is a byproduct of the mundane. Ordinary design already secretes it, so invention holds no monopoly. Design is expression, and combination falls in behind intention. This section explains why technology does not evolve the way living things do, and what actually gives rise to a genuinely new technology. Darwin's mechanism fails for technology. No accumulation of small variations turns a piston engine into a jet. As the old line has it, add successively as many mail coaches as you please, and you will never get a railway. Arthur's answer is that a radically novel technology uses a new principle. Invention is the act of linking a need to an exploitable effect through such a principle. That linkage is a recursive chain. Each solution spawns sub-problems, and each sub-problem demands its own sub-solution, down and down until you reach what can actually be built in physical matter. The principle is never conjured from nothing. It is always appropriated, borrowed, recalled from somewhere it already existed. The creative heart of invention is mental association over a large accumulated quiver of functionalities. The source is not a spark of individual genius. It is the reach across a stocked repertoire of known effects. This section explains invention as combination under association. Darwin's engine, small variations accumulated by selection, cannot make a jet engine. Add mail coaches and you never get a railway. Arthur's replacement is this. Invention is a linking. A need sits at one end, an exploitable effect at the other, and a principle bridges the two. That link is a chain whose every link raises its own sub-problem, which demands its own sublink. The structure is recursive, and it keeps going until each sub-problem bottoms out in a part that already exists. So, origination reduces to combination under association. The maser, the cyclotron, and the laser printer are all the same move. Here is the inversion. The whole account turns on. To invent something is to find it in what previously exists. There is no creation from nothing, and no genius, only a large quiver of functionalities, and the association that connects a problem to one of them. This part explains why complexity accumulates in mature technologies. push any technology, and some part hits a wall. Photolithography meets the wavelength of light. Turbine blades soften at temperature. You can replace the impeded part, but more often you retain it and hang a new assembly on it to route around the limit. A bypass airflow to cool the blade, a bypass airflow to gate the radar echo. That added assembly is itself pushed, meets its own wall, grows its own workaround, recurse at every level of the hierarchy at once. Complexity is not designed in, it precipitates, each subsystem the fossil of a limitation once survived. Whittle's turbojet had a few hundred parts, its descendant has 22,000. Elaboration as a crudojet had a few hundred parts, its descendant has greeted sediment where pressure meets boundary. This section explains structural deepening, the reason complexity accumulates in engineered systems and in theories alike. Take a crude base principle and push it against its first barrier. The principle survives and gets wrapped. Developers hang a subsystem on it to work around the limit, and that subsystem, pushed in turn, grows its own. So complexity becomes the fossil record of every limit the system ever hit. Whittle's single compressor becomes 22,000 parts, and the multiplication is encrustation rather than refinement, each layer a scar over a wall. The base principle could not pass. The reflex recurses to every level, and to theories too. Kuhn's epicycles are the same move. Here is the tell that reveals the structure. Elaboration only ever accretes. Simplicity never comes from pruning the old. It comes only from a new, simpler principle arriving to restart the cycle. This section explains the difference between adopting a technology and encountering a whole domain. A single technology is adopted, it gets dropped in, and the economy adjusts around it. A whole domain is encountered, and encounter runs both ways. The industry recombines its own procedures with the new domain's functionalities, and the domain grows new functionalities, and the domain grows new functionalities to fit. Banking is the clear case. It did not simply adopt computation. Some accounting merged with some of computation's algorithms, and digitized accounting was born, and then a whole industry, financial risk management. That merging is what we call redomaining. The accumulated, decades-long co-adaptation of economy and domain is what we call a revolution. Trade the idea of insertion for the idea of mutual recombination of two collections of parts, and the 40-year lag stops being a puzzle. This section explains the one idea Arthur's whole chapter turns on. It is a single substitution. The economy does not adopt a new body of technology. It encounters it. That one swap is the generative primitive. Consider what a domain is. It is a coherent family of devices, methods, and understandings emerging on the scale of a decade, never invented but crystallizing out of a parent field. A domain like that is not a tool an industry picks up. It is a second collection of functions that collides with the industry's own functions, and from that collision, both sides recombine into something neither held before. This is just the combination operator of the earlier chapters, lifted from single devices up to whole domains and applied to the economy itself. When the recombination runs deep enough, we call it a revolution. This section explains why technology evolves the way it does. Technology builds itself from itself, an autocatalytic set. Every new device is combined from ones already present. The triode becomes radio, then the oscillator, then logic gates, then computers. So the collective becomes its own supply of parts. Combinatorially, n elements yield approximately 2 to the n possible combinations, and the supply explodes past a threshold. The move that closes the loop is on the demand side. Most opportunity niches are opened by technologies themselves rather than by human need. Each new means spawns the need for the next. Supply self-generates, demand self-generates, and the system is autopoietic, needing only humans as the coral needs its polyps. Here is the boundary. Nothing here is designed. Direction emerges from closure rather than from intention. This section explains why technology grows on its own, treated as a closed system. Technology is a set closed under one operation, combination, where every product re-enters as raw material for the next. That closure is the entire thesis. The collective is its own supply, and the needs each new element spawns are its own demand, so the system bootstraps with no input but human agency. Arthur's word for this is autopoietic, meaning self-creating. Complexity becomes reachable against absurd odds only through stepping stones. The simpler circuits must exist first, before an 8-bit adder can be combined into being. One contrast fixes the structure. Biology combines two, but only through a Darwinian bottleneck. Here, combination is unbottlenecked, the everyday norm, where in biology it stays the rare event. This section explains a single figure, ground inversion, at the heart of the chapter. Start with the standard picture. It makes the economy a container, a fixed machine into which technologies slot as replaceable modules, with the rest of the system rebalancing around whatever slots in. The economy holds the technologies. Arthur flips figure and ground. On his view, the economy is not the container of its technologies, but their expression, the thing they throw off. It is the standing structure draped over them, the way a mind emerges from its concepts, or an ecology from its species. Once you see it this way, the causality closes into a loop. Technology forms the economy's skeleton, and that skeleton decides which new technologies get to enter. Technology creating the economy. So the economy does not merely readjust when a technology arrives, it reforms. That circular closure is the whole chapter. This section explains why the economy is better seen as a structure built from technologies than as a box that holds them. The instinct is to picture the economy as a container holding technologies. Invert that. The economy is the standing structure that forms from those technologies, activity draped over a skeleton of purposed arrangements, running from steel mills to contract law. Once you see this, the evolutionary engine from Chapter 9 runs unchanged, one level up. Each new technology calls forth accommodating arrangements. Those arrangements breed new problems. Those problems open niches for further technologies. That is structural change, fractal, self-triggering, never at rest. The surprise that reorganizes everything is the circular causality. Technology builds the economy, and the economy selects which technologies enter it, so it perpetually creates itself. Arthur's textile mill example is just this loop caught over a century. Machinery leads to the factory to labor, labor to cities, and cities to labor law. This section is a recapitulation that turns. The book's whole argument compresses to one line. Technology creates itself, out of itself. Combinatorial autocatalysis feeding on captured phenomena. This closing chapter runs that primitive forward and finds it crossing a boundary. As technologies become networks that sense, configure, and self-heal, the vocabulary needed to describe them turns biological. Mechanism versus organism is revealed as mere viewpoint. Look top down and you see clockwork. Look bottom up and you see a functioning body. And since technology is nature programmed to purpose, it is profoundly natural, yet does not feel so. The chapter's telos is the moral kernel this leaves. Judge no technology by what it can do, but by whether it extends our nature or deadens it. This section explains the closing move of the book, that whether a technology reads as mechanism or organism is a matter of viewpoint. Technology is the programming of nature, phenomena captured and orchestrated to purpose. From that single premise, the book's closing move falls out. Whether a technology reads as mechanism or organism is not a fact, but a viewpoint. Top down, it is clockwork. Bottom up, it is a functioning body. As technology matures, sensing, self-configuring, self-healing, the organic reading wins. It becomes as much metabolism as mechanism. The economy inherits this and turns generative. The irony raised back in Chapter 1 resolves here. We hope in what we do not trust, because programmed nature is profoundly natural, yet does not feel so. The residue is one distinction. Technology that extends our nature affirms life. Technology that deadens it brings a kind of death.